Today we will learn about the chemical diversity of the organic compound. First, make your concept clear about the chemical diversity. It means that the organic compound exhibit vast variety of the different molecular structures and properties. There are unlimited number of organic compounds with the different molecular structure and different properties. Now, this phenomena is called chemical diversity. Now it is important to learn about the reasons behind this chemical diversity of organic compounds. There are two main reasons. The first reason is catenation. Catenation is the ability of the carbon atom to bond other carbon atoms to form long chains, branch chains, and rings. Carbon has four valencies, so it not only make bond with other elements but also make bond with carbon atoms in the form of branching, long chains, and ring structures, also known as self-linkage property. And due to this self-linkage property, carbon can form unlimited number of different structures. It is interesting to ask about either this self-linkage property or catenation is a unique property of the carbon or it also exists in other element. The answer is yes. No other element can compete with carbon in this regard, because carbon show this self-linkage property up to 1000 of the carbon atom. Silicon and few other elements can also show the property, but up to few atoms, and the chain they form are very short. In the case of the carbon, the 1000 of the carbon atom link together and form the chain. The second reason of chemical diversity of organic compound is isomerism. Now, what is the isomerism? The answer is the compound that have the same molecular formula but different arrangement of the atom in their molecules are called structural isomers, and this phenomena is called isomerism. So in the case of the isomerism, the molecules have same number of the atoms but the arrangement of these atoms in molecular structure is different. And this phenomena is very common in the organic molecule. Here in the case of N-butane and isobutane, the structural arrangement of the 4 carbon and 10 hydrogen is different in both molecules. In N-butane, the carbon and hydrogen are attached with one another in a straight line, or we can say in a linear order, whereas in the isobutane, they are arranged in a branch-like structure. But the composition and the number of the carbon and hydrogen atom are same, and molecular formula is C4H10. Again, also show the phenomena of the isomerism. Here in the case of the 1-butene and 2-butene, you can see that the position of this carbon to carbon double bond is different. Here in the case of the 1-butene, the double bond is between the carbon 1 and carbon 2, whereas in the case of the 2-butene, the double bond is between the carbon 2 and carbon 3. So you can say that these two compounds are different in the position of the double bond between the carbon atoms. But the number of the carbon and hydrogen atom are same in both cases, and that's why the molecular formula is C4H8, that is same for the both of molecules. Here you can see, just by changing the position of the double bond, you may have the chemical compound with a different structure. So in this video, we tell you how the catenation and the isomerisms makes the organic molecule chemically so diverse. Thanks for watching our videos. For more conceptual chemistry videos, don't forget to subscribe our channel and press the